To my channel. So today in this lecture we are going to solve some problems of maximum likelihood estimation. So in this problem, question number 1, there are three random variables which are IIT random variables following uniform distribution with theta and theta square. So the question sought to determine the maximum likelihood estimator of theta. So we are given that it follows uniform theta and theta square. So the PDF of x will be, and there are three random variables x1, x2, x3. So the PDF will be theta square minus theta 1 by theta minus 1. So the likelihood will be 1 by theta minus 1 to the power whole cube. So the usual differentiation of the likelihood function will give absurd result. So we take recourse to the order statistics or the indicator function. So here attached the theta xi and theta square. Let it be see if it has no use. I theta. Let's break this xi with respect to their order statistics. X1 dot 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 the maximum order statistics xn. It will be inclusive, okay, and theta square. So here we see that theta is less than equals to x1. This means x1 is greater than or equals to theta, and from these we see xn less than equals to theta square, that is xn less than equals to theta for n equals to 3, that is root over x3 less than equals to theta. Now theta lies in this range to x3 and x1. Now we see this likelihood. We need that value of theta which maximizes the likelihood. This means theta has to be minimum. So the minimum value of theta is root over x3. Therefore root over x3 is the MLE. So option B is correct. So in this problem we are given the probability density function and we have to determine the maximum likelihood estimator of theta. Okay, we are given f of x to be thrice alpha x square e to the power minus alpha x to the power whole cube, where x greater than 0 and alpha is also greater than 0. So let's write the likelihood function L of alpha to be thrice alpha to the power n product of I goes from 1 to n xi square and e to the power minus alpha summation I goes from 1 to n xi to the power whole cube. Now taking log on both sides, it will be n log thrice alpha plus summation I goes from 1 to n log of xi square minus alpha summation I goes from 1 to n xi to the power cube. Now differentiate this log likelihood with respect to alpha. and equates to 0 will imply n by trace alpha into 3 plus, there is no involvement of alpha terms here, so it will be 0 and it will be minus I goes from 1 to n xi to the power whole cube equates to 0. This implies n to the power alpha is equals to summation I goes from 1 to xi whole cube. So here alpha cap mle will be n to the power n divided by I goes from 1 to n xi cube. This is the mle. So our answer is question number A. So let's proceed to the next problem. Here the problem is exactly the same. The main difference is that the earlier problem follows uniform theta and theta square, and this problem follows theta and 5 theta, uniform theta and 5 theta. It's given in uniform theta and 5 theta. So the PDF will be f of x 1 by 4 theta. Right? So the likelihood will be 1 by 4 theta to the power n. Indicator function theta xi, sorry, it will be xi inclusive of 5 theta. Fine. So this term has no use in the differentiation, so let's write it to be C. And breaking the indicator function, breaking the sample values and ordering it, we get x1 dot 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 xn less than equals to 5 theta. So we have theta to be less than equals to x1 and xn less than equals to 5 theta. That is xn by 5 is less than equals to theta. Therefore theta belongs to this range. Okay, make it inclusive, no problem. Xn by 5 comma x1, it will be closed interval. Okay, in the last problem also it will be closed interval. Now we need that value of theta which maximizes this likelihood. Now what we need minimum value of theta. Now the minimum value of theta is xn by 5. Therefore theta cap mle is xn by 5. So let's stop here. In the next lecture we'll solve some more problems of maximum likelihood estimation. So keep sharing the videos and subscribe the channel. Thank you.